Hello everyone, welcome to the video lecture series on double integration. In this video we shall continue our discussion on change of order of integration. Let us take up an example. Here in this video I shall be dealing with two examples. This is the first one. Here we are given the double integral f of x comma y dx dy, and the limits are, the variable limits are for x y square up to 2y and y going from 0 to 2. Now as I said, if you find this way of representing little difficult, you can simplify it and write in this manner. You write down the limits for which variable they are. So the innermost integral, we can see it is for the variable x, the limits are for the variable x, and the limits of the outermost integral are for the variable y. Now immediately when you write this, you can understand that the curves involved in the following double integral are x equals to y square, x equals to 2y. Alright, those are the curve. So let us draw them on the x-axis and y-axis. So I have drawn here, and now I'll draw the curve x equals to y square. This is how the curve will look like. Now when I draw the line x equals to 2y, how it will look like? It will be a slanted line passing through the origin. Okay, when I draw this line, I'll be able to get the equation over here as x equals to 2y. Okay, now obviously you can see that y equals to 0 is the line, so that means it is the x-axis, and y equals to 2 is also a line. We will deal it with soon. Let us see now further. We will need to calculate, there is an intersection of the straight line x equals to 2y and the parabola x equals to y square. So let us calculate the intersection point between the two. I have always told you that anytime you have two or three curves, then if there is any intersection point, you need to solve for it. Okay, so let us see how to go for it. So when I substitute x equals to y square in the other equation, x equals to 2y, I get 2y equals to y square. Now it's a quadratic. This quadratic gets solved here as y times y minus 2 equals to 0. So you get y equals to 0 or y equals to 2. Okay, now when y is equals to 0, obviously the origin is the point. We can see it from the diagram also. So we have that one point for sure. But when y is equals to 2, we have another point as a 4 comma 2. Okay, so x coordinate you are getting as x equals to 4. Substitute in the equation, you will get it. You can put it in x equals to 2y. It's straightforward, you will get that. Okay, now let us plot those points. So those points are going to be over here. So on y-axis you can see that it is 2, and on x-axis it's going to be 4. So this is the point A, 4 comma 2. The most important decision now that is to be made is which region should I shade. Okay, the region that we are supposed to shade over here, that becomes the crucial, because which one, either is this the region between the two curves, or is it the one here, or is it this triangle, or outside, or the below, or the bottom? Where should we go? So let us understand it from the equation of the equations that are given in the limits and the function, the order. Here they are saying that it is dx dy is the order. That means it is a region of type 2. Alright, okay, so the projection is supposed to be taken on y-axis. So 0 to 2 is the projection. That is the first thing, we got that. Now you observe the curve is entering in the parabola, okay, and it is exiting at the straight line. So it means that the parabola entry point should be the first, then next should be the curve, straight line. Alright, so it means the following is the shaded region we are supposed to take care. You see here the projection of this region, the shadow of this region on y-axis is 0 to 2, and if I draw a horizontal line, obviously it's going to enter first in the parabola and it is going to exit at the straight line. So I am able to shade this region as given to me. Okay, so from the given integral, this much information you should be able to derive. Okay, this is the skill that is required in order to understand the double integration theory and apply it while the solving of the problem. Okay, now starts the question. We have to change the order. We are done with having the all the region calculated, limits calculated, everything. Now we have to change the order. So by change of order of integration, what do we get? We first write the double integral without the limits and change the order. So it was given as dx dy. Now it will be dy dx. Okay, so when it is dy dx, the given region becomes of type 1. Okay, so let us see, for type 1 region what do we need to do? For type 1 region, we are expected to pass a vertical straight line across the region, right? So when I pass a vertical straight line, the entry point is the red dot, and the red dot is on the straight line. The straight line is going to have equation now as x equals to 2y, which is already given to us. It will become to y equals to x by 2. So we get the lower limit as y equals to x by 2. The exit point is on the parabola, the blue dot. Can you see that? So it's x equals to y square. Now there is a problem. We have to write in terms of y equals to. So when I try to write this as y equals to, so it is going to have plus minus the square root of x. Then which square root should I take? It's going to be positive. We have brewed upon the concept, and that is now the concept is going to help us over here. That is because it is in the positive first quadrant. Okay, we will be taking positive square root. So here we get y equals to root x as the upper limit. Okay, so again, now we will be going for finding the projection. The projection is very much clear from the diagram, that is from the origin to 4 over here. Okay, on the x-axis you can see. So the projection is from x equals to 0 up to x equals to 4. So this is the what you call the double integral that we have got after doing all calculations. So let us see on a simple note, how do you write this? On a simple way, it is generally written in this manner without those variables inserted here. The extra like simple way of writing, it is dy dx you write, and the function is as it is. The limits are going to be x upon 2 to square root of x, and the outer limits, the constant limits, are going to be from 0 to 4. Okay, so anytime whenever you are asked to change the order of integration, the steps that are needed are: number 1, you write the integral properly and then see the curves involved in it. Second, if any intersection points are required, calculate those. After having calculated those, you have to understand what type of region it is and check for the projection, and once detected the type of the region and the projection, shade the correct region of integration. Having done that, you are almost done with the half part of the solving of the order change of order of the equation. What you do then is you go for the other type, and then you follow the theory that is taught to write the double integral when you understand the order has been changed. Okay, so accordingly you write that either you need to draw a vertical line or a horizontal line. In our case right now we drew a vertical line. Okay, so the few steps are there you need to remember. The first step is first find the type of the integral that is given to you, then check the curves involved, then you go for the intersection points, check the region, what type it is, and then you see the projection and the curves involved. Shade the region of double integration, change the order appropriately as per the theory. You will get your answer for sure. Let me take up a similar question. Observe here, in this question what we did is that this region between the parabola and the straight line has been taken, right? And you can see that between the first given question and the answer that you obtain, there is very uh, much less connection to just guess the answer straightforward from the given question. Okay, you cannot guess out the answer that okay, this will be the answer. Okay, so there is no random choices, as I told you in my previous video also. So now let us take up a similar example on the same diagram or similar kind of thing, and little bit change in the question. We will understand how the region will change and little bit changes will happen. Let us see the next question here. Here I have said change the order of integration for the following function. The function is f of x comma y dx dy, but the limits are now going from 0 to y square, and the outer limits are from 0 to 2. Okay, now same way I'm straightforward drawing the curve that are involved. The first curve I can see it is here x equals to 0, that is y-axis, and the another curve is x equals to y square, so that's the parabola that we already drew. The outer limits are y equals to 0 and y equals to 2. So y equals to 0 is going to be the x-axis and y equals to 2 is the straight line. Okay, now comes another important thing, is the point of intersection. So the line y equals to 2 and the parabola are intersecting, so we find that there is a point a 4 comma 2 involved. So that is the point we draw. The next thing that is required is the shading of the region. I have shaded here the region. Let us see how. Obviously here you can see that here the projection is from 0 to 2. Okay, 0 to 2 on y-axis is the projection, but observe here the region given to you, the type of double integral is for type 2 region. That means you need to pass the the horizontal line is to be passed across the region. So when the horizontal line must have been passed, it must have first entered the x equals to 0 equation. That means it is the y-axis. So it must have entered the y-axis first, and then it has exited the parabola y square equals to x. So when this must happen, it has to be the following shaded region possible here. Okay, because if you draw over here a horizontal straight line, it is obviously here you can see that it is entering the what you call the y-axis, and it is exiting the parabola over here. So this is very crucial from the double integral. So this much information when you are able to derive from the integral, we further go and check that this is because we have already been given that it is type 2 region. Now when we change the order of the integral, we are going to get it as a type 1 region. Now when we get as a type 1 region, what we are expected to do is dy dx is the order. So you draw a vertical line passing through the region. When the vertical line is passed, the entry point is the parabola again. So entry point being parabola, so y equals to square root of x. Okay, because of the positive in root that we are going to take, it is in the first quadrant that we can see. So the lower limit is y equals to root x. The upper limit is going to be y equal to 2, because you can see the curve is exiting, the line is exiting at the curve y equals to 2 over here. So that goes there. Okay, and the projection, now the projection is on the x-axis now for type 1 region. So it's going to be from 0 to 4, remember here. Okay, so x equals to 0 to x equals to 4, this is the projection. Hence my final answer after change of order of integration is going to be double integral f of x comma y dy dx. The innermost integral is going to be square root of x up to 2, and the outermost integral is going to be 0 to 4. Okay, the limits for x, those are the constant limits. Okay, so this is how we do the change of order of integration. Compare the both the questions. Okay, and in almost there is a great similarity between the two questions, but I want you to understand them that the region has shifted. The first time it was that region bounded between the parabola and the straight line, now it is between the straight line and the parabola. Okay, so check out how it is done. Okay, please go through the entire video once again, and I request you to think about the entire concept of how to shade the region. It's very crucial. Okay, so for this lecture I have given you this content, so I hope you liked it. Please hit like button if you have followed the concept, and share it with your friends and other students, those who are in need with the double integration concept. And if you have any kind of doubts related to the topic, please post your comments in the comment section. Till then, thank you, and keep solving good amount of mathematics.